Hi guys, I'm Andani Madodonga working with Yurana Kalashe on COVID-19 South African Consortium project. We are basically trying to solve the problem that the government and health institutions are facing with regards to the spread of misinformation relating to COVID-19 on social media platform. So we have used machine learning techniques to address the gap that is faced by government and health institutions by means of creating baseline for risk communication strategies. We therefore identify three goals, that is identify and cluster the dataset into a local and global category, and identify, describe, and quantify the spread of information in the dataset, and lastly, perform sentiment analysis across various groups of identify spread of information. To achieve these goals, we have used two datasets, original dataset, and then we have used feature engineering techniques to create sub-datasets, which left us with 20 features. In the process of building the models, we have made few assumptions on influencer status, dissemination of microblogs, trending status, hourly rate of transmission, and lastly, we assume that the microblog with similar characteristics will have similar rate of transmission. And then we have built main 4 models to achieve our goals. First model was built to classify South African and international microblogs, of which we trained several models, but random forest outperformed all of them with recall accuracy and F1 score of 96%. Also validated the model on unseen data sets, which performed very well, got 97 accuracy. Also checked the stability of the model by introducing noise into our model, which gave us accuracy and recall an F1 score of 99%. After clustering this data into global and S8 data, we performed the sentiment analysis on each group. As the 2 bar graphs shows the sentiment results. The second model, we trained it to classify microblog user influencer status, of which we trained 3 models: Expose, KNN, and Logistic Regression. And then, as you can see, XGBoost outperformed the 2 models with accuracy recall F1 score of 100%, and also check the model on unseen data, also gave us 100% accuracy. And then the bar graph below shows the result of our model.
The third model that we build is with respect to identifying the probability of a microblog trending. We also used accuracy and F1 score to determine our optimal model, which was the random forest, giving us a 97% accuracy and an F1 score of 98%. Our stability rate also showed high accuracy and high F1 score of 91% and 97% respectively. We also did a feature importance plot to determine the most optimal features for this model. And we also determined the sentiment between the 2 clusters of not trending and trending. Lastly, we determined the rate of transmission of a microblog by creating a regression classifier by using XGBoost, random forest, and neural network. From our model results, we found that the XGBoost model had the lowest mean squared error. From there, we determined the distribution fit of our counts of retweets for each microblog based on its topic, and we found that the Poisson distribution had the most optimal fit. And lastly, we were able to determine the distribution plot for each count for its first 72 hours of its life based on the topic or category for the microblog. So after we built our models, we deployed our visualizations and models onto a Streamlit app for ease of access for the officials, such that they can use at their own time. So we deployed the most important visuals on the Streamlit app, as you can see. And then we also have a section for prediction where you can actually predict using the previously discussed models. So you can use the original data set to either predict categorization, sentiment, and influencer. And you can also either do a bulk prediction where you predict by uploading an Excel file, or individually by uploading a specific text. So you can do that for each of the classifications. Then you can also use the sub-data set as described to actually predict the rate of transmission of your data set or the probability of your data set trending. So for this, you also have bulk prediction as well as single prediction, where with bulk prediction, you can upload an Excel file, and with single prediction, you can just key in the most important features as described by the feature importance plot to actually get your rate of transmission as well as whether your microblog will trend. Thank you so much.